so let's now move on to a very, very important part of the chapter, dealing with e to the x and ln x. So we've already established that the graph of 2 to the x, for example, looks like that. And we also established that the inverse function of 2 to the x is the logarithm base 2. So the graph of log 2 of x, which is the inverse function of 2 to the x, looks like this. Remember that we said if, say, 2 to the x is 8, for example, so you can observe that x is 3, okay, then log 2 of 8, which is 3, is the reverse. So if you log that side, you get back to that power, and vice versa. So log base 2 of x and 2 to the power of x are inverses. If you log an x and you do 2 to the power of x, they go in circles and are reverses of each other. Now, if we look at when the base is e, remember e is the special number such that e to the x, where e is a number approximately 2.71, has a derivative, i.e. a gradient function that is exactly the same as the original function. dy by dx of e to the x is e to the x. So it has a very special part to play in maths. So now let's look at e to the x. Okay, very similar to this. So e to the x has a very similar shape, and the logarithm base e will behave in a similar manner. Notice the y-intercept of e to the x is 1, e to the 0 after all is 1, and the x-intercept of the logarithm base e is 1. We know this because log of 1, remember we discussed log of 1, any base is 0, because anything to the power of 0 is 1. So when you put 1 into a logarithm, you get 0. So the output, which is y is 0, i.e. the x-axis, would be 1. Now log base e has a special name. It's called ln, or ln for short. So ln x, or ln x, is the logarithm base e. So instead of writing log base e of x, log base e has a special name, and it has a special button on your calculator. That is the definition of what we call ln x. So what that means is that e and ln are nothing new to what we've learnt already, except we might apply them in a slightly different way. So let me show you what I mean. So we've already learned that if you were to solve e to the 5x minus 1 is equal to 10, using the old technique, as so to speak, of what we've done before, you might say, well, I'll turn that into a log. I'll say log base e of 10 would be equal to 5x minus 1. And we've now learned that log base e, we don't really write log base e, which you can, but that's ln. So that's ln of 10, which you could compute using the ln button on your calculator, is 5x minus 1. And then we could rearrange from there, such that x would be ln of 10 plus 1 divided by 5. That would be an exact solution, and then we could work that out for a specific decimal place accuracy if we wanted to. Now, similarly, if we had ln of 3x minus 2 is equal to 8, you could say, well, I know that ln is log base e, and we could use ln as if it's a log, so e to the base of 8, so e to the 8 is 3x minus 2, and therefore rearrange, you get e to the 8 plus the 2 divided by 3. However, we could skip some of these steps to be a little bit more efficient and effective. So when dealing with e and ln specifically, although it's no different, e is still a base and ln is still a logarithm. Okay, it's no different to the rest of the chapter. However, we could skip some steps here, which would allow us, for example, to go from here to here, and from here straight to there. So let me show you what I mean. Because e and ln are reverses of each other, you can apply them to eliminate the other one. So for example, If I've got x squared, how do I get rid of squared? I use the square root. If I've got x plus 2, how do I get the plus 2? I do the minus 2. So you can exploit the fact that they are reverses, inverse operations of each other. So what we effectively need to appreciate is as follows. Okay, if I have e to the x is equal to k, just some number, ln will cancel the effect of e out. Ln and e cancel each other out. It's like squaring something and square rooting something. You just end up back to where you started. So e to the x, if I apply ln, on both sides, then the ln and the e cancel out and the x drops down. So ln of e to the x is effectively just x. So if you want to get rid of e, i.e. you want to try and get to the x or the expression that has x at the top here as a power, so e's in the way, I want to get rid of e. So I'll introduce ln. But if you introduce ln, you have to make sure there's nothing there. Otherwise, ln and e will not cancel. Ln and e can only cancel if there's nothing there. So in this case, x is ln k. Which also makes sense, because if you write ln as log base e of e to the x, we've seen using logarithms, that's also x. Log base e of e to the x is x. Now, what happens if I have ln of, let's say, 3x minus 1 is q? Again, I want to get x. I'm trying to solve this equation. I want to get rid of ln. So how do I get rid of ln? I introduce e, because e will cancel ln. However, when you introduce e, e is a base. Okay, you cannot multiply this by e. E is just a number. You can't just multiply by e, right? You can cancel e and ln if e is introduced as a base. So if you want to get rid of ln, then you have to introduce e as a base, which means that becomes a power. And if I introduce e as a base on the left-hand side, e has to become a base on the right-hand side. Now e and ln can cancel, and that will drop down. 3x minus 1. And then you can rearrange from there. So effectively, I would now like to introduce the two main rules how to introduce e and ln effectively. It's as follows. We say e to the ln x, but it doesn't need to just be x. It could be 2x, could be 2x plus 1. E to the ln x is just x. And ln of e to the x is x. So that's the legal moves for cancellation. So that's very important. And we'll relate this back into this example in a minute. Now, what you need to worry about is if there's numbers in the way. Now, if there's a number in the way here, it's less of a problem than over here. So let me show you what I mean. So let's suppose that I have a term, okay, 2e to the 3x. I cannot put a ln there because the ln and the e won't cancel because of the 2. You could ln 2e to the 3x and then you'd split it up. So if you introduce a ln here, it's not a problem, but you need to realise that's not going to be 3x because the 2's in the way. So you could introduce a ln and then it would become ln 2 plus ln e3x, and then the ln and the e would cancel, and that would become ln 2 plus 3x. But if you can, depending on the equation, it's better, divide through by the 2, get rid of the 2, and then you can introduce a ln like normal. So that's one important consideration. Another important consideration is when there's a number stopping you introducing the e to cancel with the ln. So for example, if I have 5 ln 1 minus x, and I want to introduce e to cancel with the ln, if you introduce it now, the 5's in the way. The 5's in the way. But here we have an extra option. E is not a logarithm, but ln is. You have to remember the back of your mind, ln is a logarithm, which means the 5 can quickly be put out the way without further calculation, because you can just put the 5 up here. So you do e ln 1 minus x to the power 5. Now the e and the ln will cancel, and that becomes 1 minus x to the power 5. Once again, you can also eliminate the problem, and usually this is the best way, is just dividing through by 5. Divide both sides by 5, and then the e and the ln can happily cancel, and you won't have 1 minus x to the power 5, you just have 1 minus x. So whatever's on the right hand side, you can divide by 5. So going back to these questions here, now we realise, I've got an e, let's get rid of the e, let's apply ln. So I'll ln both sides, ln e will cancel, I go straight to 5x minus 1, ln of 10, so you see I've gone straight from here to here, because ln and e cancel, and we can go to that line. Similarly here, right, I want to get rid of ln, so let's introduce e as a base. Introducing e as a base will cancel directly with ln, so leaving me straight to 3x minus 2. Remember, if you introduce e as a base, it doesn't become 8e or e8. It becomes e to the power of 8. And then we finish the problem off. So let's use the knowledge we've learned to have a go at this problem here. Here you've got a sketch of the graph y is 3 plus ln of 4 minus x. And they've labelled the x-intercept and the y-intercept a and b. Y-intercept a, x-intercept b. It says find exact coordinates for a and b, which means leave any coordinates in terms of exact form, i.e. e and ln in this case. But it could also mean in terms of a surd or in terms of pi, which is something that comes up a lot later in integration. So have a go at this question. Copy it down, find the exact coordinates for a and b. It was 4 marks, 2 marks for each intercept. Right, let's go through it. So a is where it hits the y-axis. Remember, it hits the y-axis when x is 0. So to find a, you have to insert x is 0 into the equation. And out pops the y-intercept straight away. If you put x is 0 in, the ln 4 minus x just becomes ln 4. Don't forget you've got to add 3 to it. So a you can just write down straight away. A is very easy. X is 0, and it's 3 plus ln 4, or ln 4 plus 3. I prefer you write 3 first, because I'm worried if you write ln 4 plus 3, then it'll turn into ln 7. Ln 4 plus 3 is not ln 7. The plus 3 is separate from the ln. Anyway, that's the answer for A. 0, 3 plus ln 4. Now for B is a little bit harder, because B is when y is 0. Now when y is 0, you've got a little bit to do to solve the equation. So for B, let's set y is equal to 0, which means 0 is equal to 3 plus ln 4 minus x. And now let's solve. So effectively, you've got x trapped inside a ln, and we said to get rid of the ln, you introduce e. So I've got to isolate the ln where I can by itself. So I've got to get rid of that 3. Let's take the 3 across, so minus 3 is ln. And recall what we said. To get rid of ln, I can introduce e as a base on both sides. So e to the base here would be e to the minus 3. Introducing e here would pop ln 4 minus x up as a power. E and ln are now touching each other. There's nothing in the way, so the e and ln will cancel. So e to the power minus 3 is 4 minus x, and we're looking for the x coordinate. So swap that around, and then you get 4 subtract e to the minus 3, so it's 4 minus e to the minus 3. You can write that as 1 over e cubed if you want, comma 0. That's the answer for B. That's the answer for A. Final example, so again, get that down and have a go. Right, so this example here, it's about recognising that ln is a logarithm. So if there's no coefficients and you're adding 2 logarithms, you can combine them using the multiplication law. Ln is a logarithm, so you have to think you can combine ln terms. You can't combine e terms like this, but lns you can. Right, so the first thing you can do is combine 4 minus 2x and 9 minus 6 and multiply them using the logarithm law. Here, I've got that 2 there, and it's worthwhile bringing this 2 up, because ideally, if you can write ln of something equals ln of something, then the inside of those ln functions must be the same with the log. Okay, if you can write log of A equals log of B, well, then the A must be equal to the B. So actually here, I can now say that this is equal to that. So, if you cancel the lns, again, you can only do that if it's ln of something equals ln of something. If there's numbers on the outside, you've got to take care of them by bringing them up. But in this case, we can. If you multiply that out, you get this. If you multiply x plus 1 squared, you get that, and now we have a nice quadratic to solve. So bring that across, you get 5x squared. Bring that across, you get minus 32x. The 36 will go down to plus 35. And now we solve that quadratic. And if you solve this quadratic, you get x is 5 or 7 over 5. However, because ln is a logarithm, remember I've said before, you have to check those are valid solutions, i.e. that the inside of the ln, if that's negative, that's a problem, because you cannot ln or logarithm a negative number. So let's see, if you take 5, that's a problem. Look, 4 minus 10 is negative, so straight away that's a problem. Remember, even if the first one was okay, if any single term is negative inside the ln or a logarithm, that's a problem. And if you check, 7 over 5 can safely go into each of these three terms and generate a positive input into the ln, so 7 over 5 is the only solution.